So that's 100. And that's 1 bar. So 100, 100 kilopascals. Now that'd be 100,000 pascals. Got me? So put those numbers together. You know, when you see, if you're like me, when I was first started seeing Newton meters and kilopascals and all this kind of stuff, my eyes would glaze over. I don't hear all that mess. I just want to know pounds and stuff, you know. But I mean, the more of that stuff you get your head wrapped around, you know, you say 100 kilopascals is equal to 1 bar, and that's atmospheric pressure at sea level, right? Now they also can break a bar up into 1,000 like millibars, you see, all that. So just keep all that. You know, I'm trying to teach you something here, and I'm going to teach myself something at the same time.
What comes out the PSI?
What's that?
What comes out the PSI, pound per square inch?
What comes after pounds per square inch?
So a PSI is equal to what?
No, 1 pound per square inch is like 1 pound per square inch. You know, I mean, you could go the other way. You can actually put in. Well, if you go that way, you're going to get screwed up numbers that are hard to remember. But if you say 100 kilopascals is equal to 14.5 pounds per square inch, which is sea level pressure, you can remember that. But if you go the other way, you're going to get, you know, numbers that are sort of out of balance and screwed up that are hard to remember. And so if you can start from kilopascals and go to PSI, you can do better than you can trying to go back the other way. You see, and I can show you what I'm talking about here. If I clear this and I put 1 PSI, and I'm going to calculate that. See, that's 6894.745. You want to remember that? Come on now. You know, then it's a screwball bunch, you know. Or where you headed there? You got to write it down? Yeah. All right. So let's go. So pressure is measured in kilopascals. That's right. In a hydraulic system, an increase in force means an increase in speed and distance.
True.
Well, not really. Think about it. If you've got an increase in force, that means you're going to have a little piston pushing a big piston, right? In other words, you got a little piston on behind your foot, and then you got a big piston doing the work. So is the big piston going to move farther and faster than the little one? The little one's going to move, you know, if this is 1 inch and this is 4 inches, this one here is going to, you know, move 4 times as far as that one, but there's going to be a lot more power. Okay, well, it's going to increase the speed and distance. If you've got an increase in, well, you don't ever do that. You're not going to have a great big piston moving a little bitty one. You know what I'm saying? That's not any point in that. You know, I mean, I don't know a hydraulic system anywhere that does that. Where you got a big
quick shut off.
Huh?
Could be like a quick shut off or something.
Yeah, maybe that's, you know, possibly, but
the increase in force.
Increase in force means like if you got a, you know, we're talking about this Pascal's law thing. If you got a 1 inch piston here and a 4 inch piston here, this one's going to move 4 times as far as that one. See, that one, if you move that one 4 inches, that one's going to move 1 inch. Because it's 4, you know, I just made those numbers. So, but you're going to increase the force by 4 too. It's like shifting gears on a transmission. The lower gear, you know, it's like a lower gear, basically what it is. But you're going to have a ton of force right here, a lot more than that. 100 pounds here is going to be 400 pounds of force.
We're topped out, so we're not going to need any more pressure.
No, I mean, but if you got this one, if this is your actuator over here, you move this an inch, that's going to move 4 inches. And what he's saying is, if you need this to move fast for some particular reason, but heck, you better not have much resistance on this, or you're not going to be able to move that. It's going to be standing on like a brick. But anyway, that's just. But for more or less, I mean, that question may not be all that well written, but typically you're going to have a smaller piston that's snaking some pressure through lines, and it's going to be moving a bigger one. Without a functioning vent, the pump cannot circulate the transmission fluid from the reservoir. That is true. Why is that? Why does it need a vent?
For outside atmospheric pressure?
The pump has got to suck, if you can think of it that way, atmospheric pressure is what pushes it, and that comes in through the vent. But if the pressure is the same everywhere, the pump is not going to be able to pick anything up, because it's depending on if it creates, if you got a pump right here, we're just going to put a pump. And this pump is going to, because of the way it works, whether it's a piston or whether it's a gyro or whether it's a vane pump or whether it's crescent, whatever, it's going to create low pressure on the side that it's getting fluid from. And in this closed chamber, you got to have a vent so that atmospheric pressure can push on that fluid. And when this low pressure is created, see, it's actually going to go out and go somewhere with it after that, even if it's a positive displacement pump. It's not going to be able to get anything. It does what they call cavitating. That means it's making air. You know, it's just whirling. Yeah. Now, everything that comes in is going to go somewhere, but if it can't get anything, it's just going, you know, spin around, be noisy. kind of like your power steering pump's doing. All right. So that's right. Number 5, pumps create fluid pressure.
True.
That's false.
Oh.
They move the fluid, but the resistance in the circuit's what creates the pressure. Remember I told you I'm drawing these pictures of the check valve? Or the relief valve. The relief valve, the pressure is pushing against that spring until it moves that piston up and opens a little hole. And the amount of pressure it takes to move that piston that required distance is what's going to create what kind of pressure you're going to have. And, I used to do that. Like one time I had a international gas burner truck engine. I was working at Dowling Truck over at Enterprise in 1985 or whenever I was over there, early part of 85. And everything was fine as far as the clearances on the bearings and all that kind of stuff, and I had built the engine, but I didn't put an oil pump on it. It was an in-frame overhaul. You had to throw it together pretty quick. And when I checked the oil pressure, and you put the gauge on it, the master gauge like we've been doing on our worksheets out here, and I didn't like the oil pressure that I saw, but I knew there was no reason in the engine for that to be, and we didn't have an oil pump in stock for it. So I took the oil pump apart, and there's a little spring in the relief valve. And I took that relief valve out of that pin out that was holding that relief valve spring. In other words, that spring was in a chamber like this, and it had the relief valve in here like this. And whenever the relief valve, there's a little hole, bleeding off. I'm just simplifying this. And the pressure would push against this. And as the pressure pushed against that, it would squeeze that spring, and it would move this piston back and open that hole up. Well, that spring, my contention was weak. That spring was weak, and that relief valve was not operating properly. And so over here, you basically had a pin that held that spring in place. So I pulled the pin out, and I squeezed the spring a little more by putting a bunch of little washers in there. And then I put that back in there. And that made that spring stronger. The spring wasn't broken or anything. It was weaker than it should have been. And after I did that, it took more force to move that back, and the oil pressure went up to like 70 pounds. We're good to go. Now if the oil pressure is leaking out somewhere by loose cam bearing or something, you got issues. But that right there took care of that problem, and I didn't have to put an oil pump on it because the gears and all were fine. But the only thing wrong was that. But anyway, that was a one fix thing. I don't get the idea you're gonna go change the world by putting some washers under a spring. But in that case, it worked. Let's see. All pumps removed for service require a visual inspection. Have you ever? What's the last pump that you visually inspected? Who had a pump of some kind in their hand this morning? You did? Who else? Have you had a pump in your hand this morning? What about you, Willie? You had a fuel pump in your hand.
Oh yeah.
Yeah. But anyway, if you're working on something and you got that pump out, you better be looking it over real good. I
thought all visual inspection was done on the vehicle.
Well, no, visual inspection can have after you take it apart too. Okay. Yeah, that's an actual Truby there. And this next one here, most valves in automatic transmissions are check valves. You know what a check valve is? If you were going to make it,
little beady looking thing,
keeps it from going.
It'll make it only go one way, yeah. And and if you were going to draw one of those, a check valve. Let's say that you got a passage like this, and you got a ball in there, and it's got a little spring. Pressure goes this way, it unseats the ball. When it tries to go the other way, the spring seats the ball, and the pressure can't go the other way. That's a check valve, basically. Now you've also got check balls that just roll back and forth by fluid pressure and get trapped on their little hole. But most of the valves in a transmission are spool valves, not check valves. Spool valves are the little spool-shaped things that slide in these bores like we've seen, And this is a burn-in on the stuff that you learned last time about automatic transmissions. Okay, now we're hurrying here. Lands, valleys, face, and spring are all parts of a typical spool valve. Lands, valleys.
True.
Yeah, you got a spool valve. Basically, it's going to look something like that. And you got lands and valleys and faces and spring. There's a spring that'll be right here, and there may be one over there and all that. But basically, when the fluid comes in there, it pushes on that, or that actually you know, is riding in a bore that the knees will stop up holes as fluid moves that over. This one may be bigger than that one so the pressure can work on it the right way. There's all kinds of engineering that goes into that stuff. But that's basically what you're looking at there. A gerotor pump may have a constant displacement or a variable displacement. A gerotor pump is always the same displacement. There's only one kind of pump in an automatic transmission that's going to have variable displacement, and that's going to be a vane pump. And the vane pump is the little thing. It's got little radial vanes around it, and it's actually in a movable housing. It's got a spring, and it can move over, back and forth, and that can change the displacement of the pump. A gerotor pump or the crescent pump, they can't change displacement, so you're going to have the same displacement on those. A balance valve can be controlled by hydraulic pressure, spring pressure, or both. That's true. Vibration is the most common driveline problem. That's true. Yep. How many of you guys have already done the worksheet where you felt the drive shaft vibration on the Ranger? You throw the drive shaft out of balance, you spin it up, and you feel the vibration. You get to where you can tell that a lot of times that it's a drive shaft vibration because the drive shaft spins really fast. You know, it's in relation to vehicle speed. And this one of these, I think it's in this course here. We got a little study that we do on noise, vibration, and harshness. You know, and so we'll talk about that on another day. One function of a ring and drive pinion gear assembly is to decrease torque through gear reduction. Now you don't reduce torque; you're going to increase torque, right? You're going to reduce gear. The standard open differential assures that rotational speed is divided equally between both wheels. Now that's a standard open differential. You know, if you're reading this one, what the Sam hell is that? And what difference does it matter to me? That's a falsy. That's a different thing. An open differential, that's a different thing. An inclinometer is used to check drive shaft runout. No. An inclinometer is basically, what are you reading? What is your reading? What kind of reading you're going to get an inclinometer?
Isn't it the pinion angle?
Yeah. Or something here, or whatever. But you got your chunk back here with your wheels, and you got your drive shaft down here, like that. And you're going to take a pinionometer. It's going to be something similar to a protractor. Imagine yourself with a protractor and a little freely swinging pointer hanging from that, and you can hold it against the drive shaft really flat, and you can see how many degrees of drive shaft slant you got. You can actually change that a little bit by putting some wedged shims underneath your leaf springs and that kind of thing. It works pretty smooth, you know. Now that's an inclinometer deal. On independent rear suspensions, bearings are press fit on the axle. Okay, that's not true, really. They're not on the axle, they're in the hub. And what's independent rear suspension mean?
This is not, each one of the tires can turn.
No, it's not the turning. It's not the.
Independently of each other.
Yeah, in other words, if you got a suspension that's not independent, you got an axle.
A straight axle.
A straight axle, more or less. Whenever this one hits the bump, it's going to change the angle of that one too a little bit. But if you've got it set where it's independent, it's like that. So this one can go over a bump, and that one don't even know it.
Yeah.
You got me? The only way it might know it is if it's got a rear sway bar on it, but you know, whatever. But, and you don't usually do that on independent, you know, rear suspension. But anyway, I mean, I guess you can anytime you want to. Rust-colored dust around the universal joint seal does not usually indicate a problem. That's false. You know what I'm talking about? You saw that on yours, didn't you? That rust-colored dust right there around where the U-joint's going there?
Yeah.
And that U-joint on that 80 model pickup of his was one of the hardest doggone things ever tried to move. And we're trying to pull that that Pitman arm off of that Crown Victoria the other day. And so we got really aggressive with our impact wrench, and we just destroyed one of those little cheap Pitman arm pullers, and his threads just came right on out of it, you know. I'm going to send that back to Brett, you know, tell him to stick that in his ear. That was a cheap one. He sent me a really nice one, a good one. And well, he was here when I finally got it off. You could run that impact wrench up against that thing until it just plumb stopped turning, and it wouldn't go. And I don't want to use a acetylene torch, but I got that little torch out there that the little $8 bottle torch, you know, and I just put a little heat on it and pap around on it with a hammer, and it started coming in. A little bit of heat, not a lot of heat. Put a lot of heat, you burn the seals in the sector and all that. But anyway, we got it off there and put the other one on. And did you know something else? And this is kind of dumb. Like, I'm trying to parse this my own self. She was talking about how bad that thing pulls. You know, it was pulling. The car was pulling really bad. And that's why we got looking at it. And that's why we discovered that it was a little bit of slack in that pitman arm. And then all we did was change out that pitman arm. And then a different lady drove it this morning. And she said, well, the other day it was pulling, but it's not pulling today. And I didn't test drive it after we changed the pitman arm because she's in a hurry to get back to the other campus. But she claims that it ain't pulling anymore, which I can't imagine how that would have changed to pulling. I mean, but you know, sometimes if they're happy with it, I'm happy with it. Okay, when drive axles fail, one of the first symptoms is unusual or excessive noise. That's true. What does a bad CV axle sound like, guys?
Grinding?
No, the clicking.
Clicking, popping.
It's like, I drove around with bad TV axles for like 6 or 7 months.
I have noticed people pull up out there at the Volkswagen place, the CV axle they've been ignoring. You know, the boots get compromised and dirt and grit and everything washes the grease out, and then it just keeps on grinding. They pull up at the dealership and the balls fall out of their CV axle, and they're done. It's just, I mean, pull it up just about the time they pull it up, you know.
Whenever I took mine off here, took them back to the house, I pulled them apart, and like just the round thing that holds balls in on the outside of that casing.
Yeah.
It was like, it came apart in 3 pieces.
Yeah, it broke all to pieces. Yeah,
It was shattered.
that thing's doing a tough job. You got to keep it, you know. But as long as those boots are there and the grease is in there, you won't usually ever see any problem with those. You got me? In other words, as long as that boot is not compromised by, you know, being split or something. Driveshaft balance can be achieved by adding or subtracting shims from the rear transmission mount. And that is false. Universal joints can be checked while mounted in the vehicle. Well, that's true, but you will not always be able to find them that way. Anytime I'm going to check U-joints on a drive shaft, I'm going to take that drive shaft out and I'm going to feel them things. I'm going to see if they are stiff or, you know, hard or all that kind of junk. And that's about the best way to do that. This is supposed to be true according to that, but I mean, you cannot always tell if you've got them. Now, squeak, 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 click, click, click. You hear those noises? You can pretty much figure you got that. He had a ring when he put it in. Bing! It ring the drive shaft like a bell. And he doesn't hear that no more. And he's really disappointed because he was really happy with that noise. He could just shock somebody with us in the parking lot. Ding! They look around, you know. Just
What is that?
Yeah. One of the things that Tim, the guy that's in charge over here, anytime his truck has got this squeaking front, we need to put some lower A-frame bushings in it. That Dodge, you know, because you bounce it going, you know, and that rubber's moving inside they're not worn out per se, but the rubber's moving inside. This is squeaking, you know, rubber's going to do that. And he says that every time he pulls up to a light and hits the brakes, somebody looks, you know, because they hear that noise. Transmission. Okay, let's go on to Powertrain Fundamentals Test 4. And we'll try to get through quick in the next 9 minutes or so, hopefully. A transmission uses a governor to sense road speed. Well, actually, the older ones did. The older transmissions that weren't electronic, they used a governor. They actually had this thing that was hydraulic, that was centrifugally driven, and it would move little stuff inside of it. They're made in various different ways. And the faster you went, the more those weights would sling out, and that's how you knew how fast you were going.
And the governor opposes the throttle.
The governor pressure opposes throttle valve pressure. Yeah. So basically, the longer, throttle valve pressure opposes governor pressure. They do this. And as the deeper you're into the throttle, the more the governor is going to have to, the more it pick up speed and move its little counterweights to overcome. That's the easiest way to understand it. They did it all hydraulically years ago, you see. But yeah, that's supposed to be, according to this old test here, that's supposed to be true. You know, but in the newer ones, speed sensors. Yeah, speed sensors, pressure control. I mean, yeah, they do it a totally different way now. Main line pressure is the source from which governor and throttle pressure are produced, and that's right. Main line pressure. Number 3, as engine load decreases, throttle pressure increases. Throttle pressure is going to increase as engine load increases. You're going to go deeper into the throttle when you got a heavier load, am I right? So that's going to be an increase. As the speed of the vehicle increases, governor fluid pressure rises, and that's true. It's going to oppose throttle pressure.
Number 3, this is false, right?
Huh?
Yeah. Okay.
Yeah, 3 was a falsy. Most mechanically operated throttle valves will automatically adjust themselves using a vacuum modulator.
True.
That's actually the opposite. The vacuum modulator, we have talked about this before, low engine vacuum means high engine load,
Yeah.
for the most part. Okay, so if you got a vacuum line sneaking down to the modulator valve, which is the diaphragm on the transmission that's hooked to a valve inside the transmission, if you've got low vacuum, it's actually going to be like having a lot of throttle angle. Now Chrysler, they always like to have a piece of throttle linkage going down to the transmission instead of having a modulator valve. Chrysler stayed away from modulator valve. Something else Chrysler stayed away from was mass airflow sensors. They pretty much stayed away from that and stayed with MAP sensors, which I can't say I was really unhappy about that because they seem to be a little bit more solid. Anyway, let's see here. But that was number 5 was false because it'll usually either have a vacuum modulator or it'll have throttle valve linkage, but it won't have both. Now some transmissions had a kickdown valve that was where you'd have the throttle, but it wasn't a true throttle valve. It would just, when you got to a certain point, it would move the little valve and it would drop into the gear below the one it was in so you could pass. And then the electronic transmissions handle that a different way. All right, typical 4-speed transmission has 3 shift valves. Is that right? That's true. Yeah.
1, 2, drive, reverse.
1, 2, 2, 2, 3, 4. Yeah.
That, yeah.
All right. Electronic governor provides the same function as check ball and control valve governors. That's true. And electronic governor is going to consist of several components that are working together, by way of the PCM. Now, you hear PCM all the time. What's PCM stand for? Powertrain control module. And what's ECM stand for? Now, like on a Duramax diesel, if you're talking about the computer on that, it's called an ECM. Why do they call the one on a Duramax diesel an ECM and everything else a PCM? Listen to that guy. He's smart as a whip.
Wait, what was it?
If it's got a separate computer for the transmission, they've got a TCM and an ECM. But if the same computer operates the transmission and the engine, it's a PCM. Powertrain control. You got me? J1930 regulation, SAE, so get that. That's that guy, Mark Shipes, was over there in court one time with this silly deal where somebody had destroyed a engine controller at some alternator shop or something, and he had to fix it, and they were taking the alternator shop to court, and he had to witness. And the lawyer for the alternator shop came and says, now you call this a processor that you replaced. Isn't that supposed to be called an engine control module? The lawyers try to, make you look incompetent. And Mark says, well, according to the J1930 regulations, you're supposed to call it a powertrain control module, but the only thing that really matters is if you can fix the car without burning it up. And the lawyer was like, because he had never heard of the J1930 regulation. Okay. All right, let's see. We got about, now let's go through improper adjustment on a mechanically operated throttle valve system results in late, hard shifts or soft slipping shifts.
True.
That's true. If you get that thing adjusted wrong, the pressure's going to be wrong, and it's going to do things that you don't like. And if you've got one that you've left that cable unhooked from, and somebody goes driving off with deep in the throttle, he'll burn the transmission up on it. Hey, we'll burn that thing slam up. Huh? Throttle valve pressure. There you go. At engine idle. Why do they do all these acronyms? Or abbreviations? Well, the military does it big time. All right. Okay, let me pause that for a minute so that my video. So, but then I have to go another full 30 minutes, so not really. Okay, let's move on here. Let's see. At engine idle, maximum current flows through the pressure control solenoid. What do you think?
Yes.
Yeah, that's true, but why do they make it that way? Why do they fix it so that you have, why do they do it that way? Don't they want it to be, have maximum pressure? Well, they want it to have maximum pressure when things fail, because if they don't know what's going on, he's going to raise the pressure so that the clutches will always apply real solid and all that. So,
Is that like a breaker, having a breaker that's too much power going through the breaker to keep it back?
yeah, sort of, but you got maximum current, not maximum pressure, is what we're talking about here. I mean, that's why I make sure we get that right. If you've got the pressure control solenoid and with maximum current, the pressure is low, isn't it, right? When the current's maximum, the pressure is minimum. And so that way, if somebody accidentally, if a rat gets under there and gnaws the wire in two that's feeding your transmission electronics, then you're going to have all of a sudden maximum pressure. See, Granny's on park her car, and then the dog or somebody. And how many of you seen dogs chew on wire harnesses? You ever seen that? Them dogs will ruin your doggone wire harness. I don't know why, but they want some copper or something, but they and they grab it, and they'll destroy a wire harness. I've seen them make $1,200-$1,500 worth of damage under a pickup, and it was the neighbor's dog that did it. But anyway, so if you cut the wire, she gets in the next morning and she noticed that her shifts are late and hard. I mean, whenever it's holding the gears a long time, and when it does shift, it goes boom. It's hitting real hard and putting a crick in her neck and all that. And the reason for that is, if it doesn't have any, I mean, they want it to default to high pressure when there's a possibility that something's malfunctioned. You see what I'm saying? If you default to high pressure, you're saving the transmission, and the customer definitely knows there's a problem. In addition to the fact that they got a blinking light or whatever, transmission light. Just keep that in mind, though. Maximum current means minimum pressure on a pressure controlled solenoid by default. A solenoid that fails mechanically can fail in either the open or closed condition.
True.
If you see a code, if you're going to draw a trouble code occasionally on a vehicle, and it's going to say shift solenoid B performance fault. And what that means is the PCM, I mean the way I interpret it, the PCM doesn't see anything electrically wrong, but it told that solenoid to do something, and from what it got back from its, monitoring speeds and all this, and it didn't happen. In other words, I told the shift solenoid B to close, and from what happened as a result, I mean after that I could tell that it didn't close. And so I'm telling you, even though I don't see an electrical problem with that solenoid, there's something mechanically wrong with it, or there's something that's in the pressure circuit that it feeds. Jimmy had one here that had a little piece of a shop rag thread hung in the bore, and the shift solenoid couldn't move that. When he pulled it out of there, he pulled that solenoid, he saw a little red piece of shop rag thread in there, and it had jammed that valve. And it was throwing him a code for the shift solenoid, this, second shift solenoid, and all that. Did you have a question? Was you about to say something?
Because I looked at in one of the books that we had, I looked at a diagram that said it could close and open or close with this. I mean,
yeah, it can stick either way. Yeah.
Either way, yeah.
Yeah, it can. Tapered roller bearings on the ends of the shafts, and this is in a manual transmission, absorb radial and thrust forces. What do you think about that? That's true, isn't it? Incidentally, you guys need to finish putting your transmissions back together that you didn't finish last semester too. That's something that's got to be done. Okay. Gear position is determined by which gear is locked to the main shaft. We're talking manual transmissions now. Is that right? Think about it. You guys that have been through manual transmission, what can you tell me about that? The gears that actually lock and unlock, which shaft are they on? In the main shaft. That's right. So that sounds like a truism there, doesn't it? Okay. Let's see. Adjustments to the shift linkage may be made with the transmission in low gear or neutral. That's false. Okay, synchronizer rings may have grooves or friction material on the inside circumference.
Sure.
That's right. That's because they've got to bite that little cone-shaped gear and make it, match the speed. And they'll and a lot of times you'll see them, they'll have something that looks like a little brake lining in there or something that basically overcomes the fluid. You guys don't know what a wet clutch is? Like when you got a clutch that's got a pressure plate and all yours, it's got oil running around it in there. And some of the equipment and stuff that we would have actually a sealed bell housing, and it would actually have a bunch of fluid in there. But you've got a clutch and a pressure plate in there, but it's a wet clutch. You seen that before? What do you see it on?
Is that for the heavy-duty dump trucks?
Yeah, some of them. What do you see? What do you see it on? Did you see it on something?
4.6 Mustang.
Yeah. So he saw a wet clutch on one of them. So that's pretty cool, isn't it? And all right, let me see. Let me get over here. Side bearing preload is measured with an inch-pound torque wrench and a tool that fits over the pinion shaft. That's true. What you're going to do is when you're setting that rear end up, and you feel like you've got that preload like it's supposed to be, you're basically going to see how much torque it takes to keep that thing turning. Preload is how much load is on those bearings before anything else happens, and that's to make sure that nothing moves in any direction that it's not supposed to move. You don't want it wallering around. Hello? I don't know who that was. They needed to talk faster than that. And I ought to take the battery out of that phone. Alright, let me see. I'm almost done here anyway. Although they're not very economical, mechanical or cable linkages are used in most manual transaxles because they're reliable. That's false. Gear and gear sets on manual transaxles are similar to rear-wheel drive manual synchromesh transmissions. You learned that last semester, guys, remember? They're similar, right? Yeah, they're similar. They're not the same, but they're similar. What's the main difference between a manual transaxle and a manual transmission and the way they're laid out? Remember?
Transaxle is going to be in the front wheel drive vehicles, and generally it can be like horizontal or east to west. And regular transmissions are rear wheel transmissions, so it
Yeah.
takes the back. It's just like my truck compared to the Escort.
If you look at the inside of it, if you were going to define the difference in the way it was put together, the main shaft, the cluster gear, and all that, how would you say that? The input shaft coming out of the engine is technically, well, it's kind of screwy because the cluster gear is not really a cluster gear because it's actually got a gear on it too. But most of the gears are not on the one that's coming out of the engine. They're on the shaft that's next to it. Right? The gears that you change, there's only one gear that's on the one coming in. They had to stack all that stuff.
What was the name of that joint on the transverse motor that used the universal joint?
Which one you talking about?
Remember the one that was a question said does a side engine use a universal joint?
Yeah, they got Rezepa joints and tripod.
Was it a Rezepa or a Camden joint? Which one?
Yeah, a Carden.
Carden joint.
Yeah, a Carden joint is like the ones that y'all were fooling with this morning. You know, on the Bronco.
Yeah, those universal joints.
But you got Rezepa and tripod joints are actually a different kind of, like what Matt Winters was fooling with this morning. He's fooling with a Rezepa joint.
Well, we were talking, you and I were talking about the engine turned sideways. You got the two shafts, you know.
Yeah.
And that shaft had a universal joint on it, which wasn't common in single.
Oh, yeah, I see what you're saying. It had a regular cross-style universal.
Yeah.
Yeah, I remember that. That was yeah. On that, I don't remember what kind of vehicle that was, though. I remember
It was in the book, and I don't think it told
or
us.
something. Yeah, they were. I've been a long time, but I don't remember. But I know what you're talking about. Yeah, usually they have a CV axle on there. All right, now let's move on down here. All transaxle models have the same disassembly procedure.
Yep.
Oh, everybody knows that's true, right? Haha, funny. Nope, that's not right. When assembling a transaxle, rotate the side gears at least one full revolution prior to measuring backlash. This ensures that the gears are firmly seated.
True.
How many guys have measured backlash on a transaxle?
Not on transaxle.
Yeah. And what's backlash again? Tell me what backlash is.
It goes to the differential and it goes to the spider gears and make sure the volume's locked in the differential.
Yeah, whenever we used to put the lash is how much click, 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 click you got between the gears is what it amounts to. That's the backlash. Valve lash, when you're talking about lash, it's always talking about clearance. Got me? And so, you know, the backlash is on your gears. Valve lash, you know, all that. Shut up. We do that noise anymore. That thing's trying to ring again. For proper transaxle maintenance, manufacturers recommend changing the lubricant only if it becomes contaminated. That's true for a transaxle, for a manual transaxle. Hello? Hey.